Good morning and welcome everyone. Thank you for joining today's webinar, which is our fourth and final in our four-part winter webinar series that's been co-sponsored by the Kootenai Conservation Program and Columbia Basin Trust with support from the Fish and Wildlife Compensation Program. Given the rich heritage of stewardship in the Columbia Basin, I'd like to acknowledge that our work occurs in the traditional territories of the Ktunaxa, Shuswap, Sinixt, and Syilx Okanagan peoples who've lived here and cared for the land, water, and wildlife for many generations. KCP, along with the Trust and FWCP, are very excited to offer this series of webinars in the theme of building restoration and enhancement projects that make a difference. The purpose of this webinar series is to share valuable information on how to incorporate ecosystem resilience into your restoration projects with practical, hands-on solutions. Through case study examples in the Columbia Basin, this series of webinars is designed to explore four key stages in project development and implementation, which are visioning and planning a project, taking action, monitoring and analyzing, and adapting your approach and sharing your results and recommendations. My name is Marcy Marr and I'm KCP's Stewardship Manager, and I'll be your host for today's webinar. Kendall Benish, KCP's Program Assistant, is also on board to ensure that our technology runs smoothly this morning. Kendall's cell phone number is in the chat box if you need support, and you can message her there. This webinar will be approximately 45 minutes with up to 10 minutes for questions at the end. Please take a moment to locate your control panel at the bottom of your screen. Please use the chat box for messaging the group or individuals, and please use the Q&A box to type in your questions for the presenters. And all questions will be answered at the end of the presentations. This webinar will be recorded and made available on KCP's website, and you'll receive a follow-up email with a link to this webinar's as a recording, along with the presenter's contact information and links to additional resources, as well as a short webinar survey. So far, we have 100 people on this webinar, and we're always interested to know who's joined us, so please respond to the two questions in the chat box. Please let us know where you're based and what your affiliation is. Thanks, I'll give you a moment to do this. Great, so good to see so many different people from throughout the Kootenays. Welcome everybody, and a few from outside. Prince George, great. Kamloops, awesome, thanks for joining us today. While some people are still joining us and settling in, I'll tell you a bit about the Kootenai Conservation Program. We're a broad partnership founded in 2002, and this year is our 20th anniversary. We'll be hosting a big celebration in September in Creston. Details will be provided in our upcoming newsletters, so stay tuned for that. Our partnership is comprised of over 80 land and water conservation and stewardship groups, government agencies, resource industries, and agricultural producers in the East and West Kootenays and Southeastern BC. And our mandate is to coordinate and facilitate conservation efforts on private land and to generate the support and resources necessary to maintain this effort. And I'd now like to invite Krista Watts from the Trust and Angus Glass from the Fish Wildlife Compensation Program to also welcome you. Over to you, Krista.
Thanks, Marcy. Hi, everyone. Krista Watts, I'm Environment Lead at the Columbia Basin Trust. Ecosystem enhancement remains a strategic priority for the Trust, which is one of the 6 strategic priorities, as well as the 2 integrated priorities of climate resilience and working with Indigenous peoples. These priorities stem from what basin residents say are important. In addition to ecosystem enhancement being a strategic priority, it's also a trust program. The Ecosystem Enhancement Program supports landscape scale projects that help maintain and improve ecological health and native biodiversity in the basin. We've put a link to the program in the chat and recommend you check it out, as there's a program guide that walks through it in detail, and you can sign up there for program notifications. The Trust initiated and is assisting with the delivery of this 4-part webinar series to help build capacity around ecosystem resilient projects as a result of the feedback we received through the Ecosystem Enhancement Program. Effectiveness monitoring is vital to a project, so we hope you'll find this presentation valuable and are able to incorporate your learnings into your ecological projects. Thanks so much, and I'll pass it over to you, Angus.
Thanks very much, Krista. Good morning, everyone. Angus Glass, Communications with the Fish and Wildlife Compensation Programme. It's a 5-way partnership between BC Hydro, the province, DFO, First Nations, and public stakeholders. And as a funder of good, sound, science-based projects, we really understand the importance of effectiveness monitoring. So we're really pleased to be supporting this session and other sessions. I really encourage you to join us on LinkedIn and Instagram. Lynn's just popping those links into the chat right now. And of course, please subscribe to our Columbia e-letter. We're hosting some great online sessions at the moment. On Friday, in a couple of days' time, it's on recovery of endangered Vancouver Island marmots. And then March 4th, Murphy Creek spawning channel, and then onwards with salmon stewardship in the face of climate change. So all of those details are on our events page. So thanks, Lynn, for doing that. And back to you, Marcy.
Thanks so much. Thank you, Krista. Thank you, Angus. And we are always appreciative and grateful to our funders, without whom we couldn't do these sorts of programs. So thank you, Columbia Basin Trust and Fish and Wildlife Compensation Program. Today's webinar includes 2 presentations about effectiveness monitoring for ecosystem restoration projects. And we're first going to hear from Dr. Michael Miller, who's a plant ecologist with LGL Limited. And he's going to be talking about the importance of conducting effectiveness monitoring and the different forms monitoring assessments can take. He'll also tell us about how to set quantifiable goals and objectives when designing a project, and how to identify the environmental indicators that can be used for measuring objectives. After Michael, we'll hear from Mark Trudeau, who's a registered forest technician and coordinator of the Rocky Mountain Trench Natural Resources Society. And Mark will be telling us about how the Big Ranch Ecosystem Enhancement Project in the Elk Valley is applying a simple effectiveness monitoring framework. And he'll take us through the steps of developing a project idea, grant application, delivery stages, as well as documenting and tracking and reporting on deliveries and long-term restoration monitoring and maintenance. So we're going to hear from both of these presenters back to back, and please hold off and they'll hold off on answering their questions until after the second one. And in the meantime, you can type your questions into the Q&A at any time, and be sure to identify whether your question is for Michael or Mark. Okay, Michael, I'll turn it over to you to share your screen and begin your presentation. Thanks.
All right, am I up?
Yes, yes, you're good.
All right, thanks everyone for joining me and Mark on this chilly morning for this presentation on effectiveness monitoring. I'm speaking to you from Coldstream in the north of Okanagan, this is the beautiful unceded territory of the Syilx Okanagan, whom I gratefully acknowledge. I've got quite a lot of material to get through here in half an hour, so I'm just going to jump right into it with an overview of my talk and sort of the topics I'm going to be trying to cover here. starting with a couple of definitions of effectiveness monitoring, or EM as I refer to it in shorthand through this talk. Effectiveness monitoring is placed in the adaptive management cycle. How effectiveness monitoring can help improve a project's outcomes. Steps for creating an EM program with a particular focus on baseline assessment, reference conditions, project goals and objectives, monitoring objectives, response indicators, and performance metrics and targets. To illustrate some of these points as I go through the talk, I'm going to pull in an example project, which is a wetland creation in Arrow Reservoir drawdown zone at Burton Flats. And I'll wrap up by sharing some ideas on sharing of results and reporting extension and so on, and wrap up with some takeaways. So what do we mean by effectiveness monitoring? I suspect most folks who've turned into this talk already have an intuitive grasp of what it's all about. You take an action to make things a bit better on the ground, and you want to know if your actions had the intended effect. That's it in a nutshell. That said, it's helpful to have a couple of formal definitions at hand. According to Matchmer and Steger, EM addresses the question of how successful a project ultimately is at restoring the ecosystem or component parts relative to its initial goals and objectives. It's the process of identifying and monitoring key indicators of ecosystem response to evaluate the success of a restoration prescription. Now here I provided another possible definition as a reminder that EM considers not just the final destination, but also the trip or the developmental trajectory. So EM assesses whether a project has moved the dial relative to baseline conditions and is on a trajectory to achieve its stated goal. With respect to shifting the system toward the end goal, this figure shows a hypothetical distribution of current conditions compared to the baseline conditions and the distance still to travel before the end goal is reached. So how does EM contribute to project success? Well, making EM an integral part of initial project planning at the outset helps improve the project design, prescription development, implementation, and overall cost effectiveness. This is because EM encourages, maybe forces, an upfront, careful explication of the whys, the goals, and the hows, or the objectives of the project before the project gets underway. Thinking through the details helps avoid pitfalls later on. Since restoration is a process, not an event, and EM enables you to view this process as it unfolds in real time and adjust on the fly as needed. In other words, monitoring helps make restoration nimble and responsive to observed changes. Through EM, unintended negative effects created by restoration activities can be recognized and mitigated before they become long-term problems applied broadly across the landscape. This graphic from the Kootenai Conservation Program shows the basics of an adaptive management cycle, from creating a vision and plan to taking action on the ground, to monitoring and analyzing the data, to adapting based on results and sharing the results with others. So adaptive management is a systematic approach to improving management by learning from the outcomes of management interventions through careful design, monitoring, evaluation, and feedback. Adaptive management is a systematic way to learn by doing, and effectiveness monitoring tells you if your actions are having the desired effect. This adaptive management cycle is unwrapped and detailed in this flowchart here. As you can see, elements of EM occur throughout the adaptive management cycle and are very prominent on the left side of this chart during the planning and envisioning stage. The flowchart also illustrates the important role of EM in facilitating adaptive management, which entails regular reassessment and refinement of goals and treatments. As shown by the feedback arrows, outcomes of monitoring can help inform changes or refinements to overall strategic priorities and to restoration objectives and prescriptions, as well as adjustments to the implementation methods, the prescription applications, and to the monitoring protocols themselves. A clear vision and goal are really the foundational elements of an effective restoration plan. In order to set clear goals, it's important to know what the problems are, as well as the processes contributing to the degradation that you're trying to fix. So for this, we need an understanding of the baseline conditions. At Burton Flats in Arrow Reservoir, Previous research has determined that the regular prolonged inundation followed by drying with reservoir level changes is the underlying overlying process limiting ecological function. The vision for the site is that by creating ponds that retain water and hummocks that stay above water, refugia are created, allowing species to persist despite changing water levels. Long-term effectiveness monitoring is currently being conducted to test the validity of this idea. I'll be returning to this project throughout the talk. Assessment of baseline site conditions is a requirement of effectiveness monitoring because without baseline assessment, there's no basis for establishing project success. Baseline assessment ensures the starting conditions are described and are quantified, establishes a basis for future comparison, helps ensure the current habitats are adequately recognized. What are the potential trade-offs of proceeding with restoration? For example, is a weedy riparian strip providing a subtle but useful ecosystem service, such as nectar for bumblebees, that might be lost if weed control measures were implemented? If baseline monitoring indicates that restoration actions are unlikely to produce a net positive trade-off in terms of valued habitat components, a decision can be made then before prescriptions are implemented to adjust the restoration approach or to seek a more suitable location. And baseline monitoring also provides an opportunity to trial, refine, and perfect data collection methods and approaches, and to make adjustments when those were needed. And it allows the success of the restoration project to be quantified, the most important component. Like EM, baseline monitoring can occur at varying levels of intensity, depending on a project's scope and complexity. In this respect, the objectives for baseline monitoring should align with the EM objectives, although they are distinct. Because baseline monitoring really represents the first phase of EM, it needs to set the stage for the information that will be collected later. For this reason, the baseline monitoring plan should be prepared in conjunction with the EM plan to ensure that appropriate data are being collected from the start. Similarly, procedures must be documented so that the same sampling procedures can be followed post-treatment. When setting your long-term restoration goals, it's also important to consider reference conditions. This is a big topic, with a lot of literature devoted to it. The reference condition is the standard against which your restoration outcomes will be compared. What would you like your site to look like or emulate eventually? Plant, animal, soil, and water data from reference ecosystems can provide end targets for restoration in similar sites. The reference condition could consist of a documented historical value, a pristine, or more often the case, a less disturbed landscape, ecosystem, or community, a comparable population, or just a professional opinion. I tend to think of the reference as a guide rather than a strict template for establishing the restoration targets or benchmarks. Because progress toward the target may be slow, taking a number of years, there may need to be incremental checkpoints and progress evaluations based on initial or intermediate targets or benchmarks that aren't technically part of the reference community. For example, in intermediate successional stage from a comparable system, such as a natural forest recovering from a 5-year-old fire, against which the developmental trajectory of a restored forest site could be compared. Now, a possible intermediate reference point for a wetland creation project in Arrow Lakes could, for example, be this reservoir impacted, but nevertheless partially functional wetland known as Cartier Bay, just south of Revelstoke. While it's also disturbed by reservoir fluctuations, it has had decades to develop. It provides some important habitat functions for wildlife, including amphibians and shorebirds, and it has been quite well studied. For monitoring restoration progress, it can be useful to frame restoration trajectories in terms of compositional convergence to an acceptable range of reference sites. For example, multiple metrics for a variety of indicators can be used in multivariate analyses to compare restoration sites with reference conditions. This figure neatly illustrates how, when it comes to developmental trajectories, there are a variety of possible outcomes depending on the interactions of 4 types of trends: convergence, divergence, progression, and deviation. So in the top left, all 3 restoration sites are progressing toward and converging on the reference targets. That's the ideal scenario. At the lower left, all 3 restoration sites are converging toward a similar state, but will end up missing the reference targets. And at the lower right, oops, sorry. Things have gone pretty much haywire here. The sites are developing in all different directions, and none of these seem to be in the right direction in terms of the target. So here's a published example of the statistical approach of using multivariate analyses to quantify progression as an increase in similarity or a decrease in ordination distance between restoration and reference sites over time. These figures are from a landscape scale study on reclamation effectiveness that we've been conducting for the last 10 years or so in the Alberta oil sands. The variable here is the similarity of wildlife communities on reclaimed sites that have been reclaimed to an upland forest type versus wildlife communities occurring in nearby undisturbed mature forest, and as intermediate comparisons to the communities that have developed on sites that are recovering either from logging or burning. The plot on the left shows the increasing percent similarity of the restored sites over time to the mature forest condition. And on the these right plots here, the numbers on the red triangles, so the numbers over these red triangles here are the number of years since restoration. You can see that the smaller numbers are associated over here. The smaller numbers are associated with plots that are more different from the reference condition in blue, whereas the larger numbers, such as this triangle here with 33 over it, where recovery has had up to 33 years, are more similar to the reference condition. So it's kind of a neat display of increasing similarity over time. After assessing the baseline conditions at the restoration site and considering reference conditions, the vision and goals can be set. Restoration goals describe the future condition of a site. When establishing the goals, it's important to keep in mind the scale of restoration. Does it involve an ecosystem process, a habitat, an individual species? As well, one wants to consider processes of ecological succession, natural disturbance regimes, and the natural range of variability that you're dealing with. For an example of a goal statement, I'll circle back again to the Burton Flats project. The goal of this BC Hydro project is to transform an existing flat, reed-canary grass-dominated floodplain, shown here in the photo, in the drawdown zone of Arrow Reservoir, into a functional wetland riparian complex of ponds and upland habitat using existing sources of ground and surface water. Once a vision is created and long-term goals have been set, it's time to get practical and set shorter-term objectives. These objectives are the specific targets or actions that will be undertaken to move the ecosystem to the desired state. Restoration objectives, as you've all heard, I'm sure, should be SMART. That is specific, measurable, achievable, relevant and realistic, and time-bound. Objectives need to be measurable so that progress toward the goals can be assessed. Ecosystems are dynamic. Therefore, objectives can be expressed as a range of values, not just as a specific number of values. It's really important to try to nail your objectives down clearly when filling out grant applications, because funders want to see you've done this. I'll note that you sometimes find that the terms goal and objective are used interchangeably in the literature, and this can get confusing quickly. Try not to get too hung up on the semantics there. Remember that in the context of restoration, your goal is what you're ultimately trying to achieve, and your SMART objectives are basically the methods you plan on using to get there. Returning to my case study at Burton Flats, reflecting the goal described in an earlier slide, the constructed objectives included: establish a descending series of seasonal ponds at Burton Flats by excavating down to the water table at 10 different elevations along an ephemeral creek course, and construct 2 elevated mounds or hummocks extending to just above the full pool mark at 440 meters elevation. This overview shot of the terrain shaping, the implementation. A series of ponds descending in elevation were created, and 2 large mounds were created over here. Some of this is vegetated because it was these mounds are constructed in 2 different phases or years. And these were created to provide upland habitat outside of the flooding zone. Now, there are numerous challenges in getting desirable plants to grow in a reservoir drawdown environment. that's underwater for much of the growing season. Therefore, the revegetation component of this project is quite elaborate, involves a number of distinct planting prescriptions tailored to different constructed terrain features and elevation bands. One of these prescriptions was to harvest existing sedges from the footprint before construction and to use these later for stocking some of the built features. Specifically, the objectives were to salvage logs and Columbia sedge stock from the project footprint prior to construction and stage in a secure water location and replant within 3 weeks onto the newly constructed pond banks at an average density of around 1,000 clumps per hectare. Moving on now to the important topic of indicators. The biotic and abiotic, these are the biotic and abiotic factors that are expected to change following restoration actions. Because we typically can't monitor and assess all the aspects of the environment or ecosystem, we focus on one or a few key components of the system, a species or process usually, to address the question, is the system responding as predicted? The indicator should be relevant to the goals and objectives. They should have a solid scientific rationale. And depending on the project goals, this could involve a traditional ecological knowledge rationale or a cultural restoration value. They should be easily measured and interpretable. They should be cost effective and unambiguous, and they should provide an early indication of change. For a wetland restoration, some possible indicators include hydrophytic plant establishment, the achieved wetland class, is it a marsh or a fen, for example? The hydro period, that is for how long and for what portion of the year is the wetland holding water, or maybe amphibian occupancy. For an upland forest restoration, some possible indicators could include deciduous tree canopy cover, ungulate winter occupancy, or occurrence of cavity nesting. Now, just as there can be an intermediate reference condition, such as a mid-successional stage, there can be intermediate or leading indicators for your project. For example, the survivorship of transplanted grabenoids or new tree cavities, the occurrence of new tree cavities. For Burton Flats, for example, we have sedge transplant success on the left as a leading indicator or a leading indicator or intermediate indicator, as you will. And on the right, wetland community composition as a primary indicator. I call this a primary indicator here because it relates more strongly to the actual end goal of achieving functional wetland habitat. Ecological indicators need to be carefully considered as they can provide misleading information about ecosystem health and progress toward end goals. So you really have to do your homework when choosing your indicators. For example, species richness is often cited as an important indicator, but richness can go through a dramatic flush shortly after disturbance, and then decline again due to encroachment of invasive species or through other natural successional processes. So that might be an ephemeral indicator. Likewise, amphibian breeding might be a positive sign of restoration effectiveness. However, Western toads often choose to lay their eggs in puddles and ditches, which dry out and don't provide quality habitat for successful reproduction. Let's take a look now at performance metrics, which are a sub category under indicators here in this flowchart. These are the specific variables that will be quantified during monitoring and later analyzed. For the indicator I've termed here as wetland class, the metric of interest might be, for example, the ratio of open water to emergent vegetation, or the type of soil, is it mineral or organic? And for the intermediate indicator for Burton Flats referred to earlier, sedge transplant success. Sorry, I got the wrong font here. That reads sedge transplant success. The performance metrics of interest might be the density per meter squared of surviving sedge plants. Here, a surveyor with Okanagan Nation Alliance is enumerating surviving salvage sedge plugs within a permanent monitoring plot at Burton Flats last year. Earlier this year, no, last year. Indicator targets are specific benchmarks that have been set for the metric being monitored. So just under metrics, indicator targets. Each indicator should ideally be assigned a target or a trigger value to assist in determining when an objective has been or has not been achieved. These may be based or I should say is on a path to being achieved or missed. These may be based on reference attribute, a reference attribute, a range of reference conditions, or some other criterion. In the top example here, the target is predicated on a trajectory related to the reference condition. And in the highlighted example, which I'll return to later, the indicator is riparian vegetation establishment, and the target is to obtain a density of cottonwood saplings that is consistent with the planting prescription. So two very different targets, one citing the reference condition and one citing the actual implementation prescription. Once we've established our indicators and metrics, it's a time to set our monitoring objectives. Monitoring objectives indicate how, when, how often, and how intensively monitoring will be conducted. The objectives for monitoring will reflect the restoration objectives, but they are different. And should also consider the appropriate level of evaluation for the project and associated constraints, such as including budgetary, logistic, and personnel constraints. Granting agencies like to see that you've given some consideration to your monitoring aims. What specifically do you hope to learn through monitoring? What's your monitoring approach and methods, and the timing and duration of monitoring activities, as well as your anticipated analysis methods? Effectiveness monitoring can occur at varying levels of intensity depending on a project's scope and complexity. This can range from routine surveillance and photo monitoring to rapid inventories of stem counts. So here and here, and to detailed cover plot assessments, for example. Together, these feed into an evaluation of whether thresholds and targets are being met. And towards the right, you get into validation monitoring, which is where you start looking at different restoration treatments and formally testing hypotheses around treatment efficacy. I've also included implementation monitoring over on the left here, even though this isn't always included under effectiveness monitoring per se. These inspections, these site inspections, document which treatments were carried out and whether those differed from the original restoration prescriptions. This information is crucial to have on hand later on in the process. After all, if you don't have a good record of what exactly was done, it's hard to evaluate the impacts. Returning to Burton Flats example, monitoring objectives with respect to revegetation effectiveness include establish around 60 permanent 25-meter squared monitoring plots stratified across different elevation zones, wetland features such as ponds and mounds, and planting prescriptions such as riparian mix, emergent mix, and mound mix. And annually monitor revegetation effectiveness within the different elevation zones, wetland features, and planting prescriptions. If you plan on doing a statistical analysis, having an idea beforehand of your statistical design will help to determine the scope and intensity of monitoring. Power analysis using baseline data may be helpful in determining the intensity of monitoring needed to detect changes in indicator metrics. You can use data from baseline assessments and monitoring to provide a sample data and an estimate of statistical variance for conducting power analyses. Statistical design and power analyses can help effectiveness monitoring validate the question of whether the restoration work is having the desired effect on the ecosystem. Once restoration actions are implemented and effectiveness monitoring data have been collected, the data must be analyzed to evaluate the effectiveness of actions. As an example of an early stage monitoring result, 1 year post-treatment, this graph plots the achieved versus target densities for various planted species at Burton Flats, including sedge plugs. Just an quick example of a summary analysis in an early stage of monitoring. After analysis and evaluation comes the sharing of results and lessons learned. Funders will often want to know at the proposal stage how you plan to finalize reports and if extensions is planned, so give it advanced thought and include it in your budgets. Reporting typically entails producing a summary report for the funding agency describing your goals, methods, costs, and interim results. Detailed photographic records are an important component of this. And future or ongoing monitoring and maintenance should be brought up at this stage as well. The information you generate can be shared with other restoration practitioners and the scientific community through journal and newsletter articles at forums like this one, and at as well as at research conferences and forums such as the annual Researchers Forum hosted by the Columbia Mountain Institute of Applied Ecology, of which I'm a director. Using newspapers, radio, and television to inform the community about your efforts benefits your project and helps more people appreciate the values inherent in restoration. You'd also consider planning and publicizing a field day to bring stakeholders and the public to your site. Or consider making interpretive signs describing your rationale and efforts. Archiving data. I suggest regularly entering and storing your numerical data and field notes in spreadsheet formats such as Excel, and if possible, incorporating it into a relational database such as Microsoft Access. Compile your photos, shapefiles, maps, and reports, including conceptual designs and as-built reports, into clearly labeled folders and store these in a single location along with any spreadsheet data. Preferably the storage location will be cloud-based, for example, SharePoint, so that it can be accessed by others as needed, but also backed up. Check with your granting agency about their expectations or requirements for data storage and sharing, because they may already have a system set up for doing this. At the provincial level, data can be shared and archived in several standardized databases housed by the government, including wildlife and plant surveys in the Wildlife Species Inventory, or WSI, natural resource monitoring information in the new Forest and Range Evaluation Program, or FREP, data on at-risk species and ecosystems stored by the BC Conservation Data Center databases, while data on invasive plants are in the Invasive Alien Plant Program database. And this will soon be expanded to include invasive plants and animals under the title Invasives BC. Final stage of adaptive management is to use the effectiveness monitoring data to reassess and refine goals, objectives, implementation procedures, and monitoring methods to improve the project's chances of success and meeting its end goals. This reevaluation process should be included in communications and incorporated into protocols for the upcoming year. By way of a closing practical example, initial vegetation monitoring at Burton Flats indicated that 2 years post-planting, the density of surviving cottonwood saplings was slightly less than the target density as per the planting prescription. Therefore, some supplementary live staking was undertaken in 2021 to fill in those density gaps. Okay, now I've provided you with a pretty big laundry list of things to think about here, and so don't get too discouraged by this, by the length of this, and I'll just end up by noting that there are very few projects out there really managed in practice to tick off all of these boxes perfectly. The main points I'd like you to take away from this are, first, that effectiveness monitoring answers the question, did actions have the intended effect? And that EM is an essential part of the adaptive management cycle for restoration. Third, that without EM, project success is impossible to quantify. Fourth, EM can be as simple as repeat photo monitoring or as complex as is required for publication. And lastly, don't leave home without these: your baseline assessment, reference condition, goals and objectives, monitoring objectives, response indicators, performance metrics, and targets. And that's all. Thanks very much.
Thank you very much, Mike. That was great information. And I know there's lots of participants who are excited that this is recorded so they can go and listen to it again and see all the information you provided. So much appreciated. Now I'd like to introduce Mark Trudeau, who'll be presenting how project partners have incorporated effectiveness monitoring into restoration efforts at the Big Ranch. So on to you, Mark. Thanks. And please, again, enter your questions for either Mike or Mark in the Q&A box. And the first ones coming in, I'm assuming are for Mike, but please identify who the speaker is that you'd like to target your question to. Thank you.
Okay, can you hear me okay, Marcy?
Yes, thanks, Mark. Go ahead.
Great, thanks a lot. And thanks, Mike, for a great presentation. Good morning, everybody. My name is Mark Trudeau, and I am the coordinator for the Rocky Mountain Trench Society. I live in Kimberley, BC, and I was hired to be the project manager for the Big Ranch Habitat Enhancement Project. In case you're wondering, no, I'm not related to Justin Trudeau. Some people like to ask that all the time. Anyways, I have a short video presentation here for you guys on sort of how we approached a simple maintenance and monitoring plan into our project. So the Big Ranch is, our project is located in the Elk Valley, which is located just north of Sparwood, BC. And the property is managed in cooperation between the Nature Trust of BC and the Ministry of Forest Lands, Natural Resource Operations, and Rural Development for the purpose of conservation of fish and wildlife habitat. The property is well recognized in the Elk Valley for its diverse ecosystems and is well supported by local residents and wildlife and hunting fishing associations. So on this particular project, the Sparwood District Fish and Wildlife Association, in partnership with the Nature Trust of BC and Flinroe, are working together to improve wildlife habitat in 3 different ecosystems: grasslands, forests, and wetlands. And some of the main objectives for the project were to create 30 new wildlife trees, manually thin 14 hectares of ingrowth forest, plant vegetative screening along high traffic areas, fertilize 164 hectares of grasslands, create 4 new wetlands, and install signs and kiosks to inform user groups of the ecosystem enhancements projects being done on the ranch. This one here. Oh, here we go. Yeah, sorry. Here is the adaptive management wheel that Mike presented earlier and has been in previous webinars. And I won't go into detail on this. Obviously, Mike did a great job of explaining this, but this is just sort of what I came across and I thought made sense, was that good effectiveness monitoring will evaluate whether projects are ultimately restoring ecosystems and their counterparts or components, and whether there's a need to refine current restoration treatments or practices to increase their effectiveness. So some of the information required at an early stage to help us guide our approach and methods were, oh, I think I might have skipped one here, my apologies. Yeah, sorry. So some of the specific steps to prepare for our project were some pretty obvious things here, but we wanted to make sure we identified our project goal and vision. We set clear goals and measurable objectives. We identified our data gaps. We incorporated a monitoring and maintenance plan into the budget, and we established partnerships. In this case here, we had the Sparwood District Fish and Wildlife Association, Nature Trust BC, and Flinroe. And we also contacted contractors and collected information on things like availability and cost. Some of the information that we required early on to help us guide our approach and methods were things like we completed a grassland health assessment. We identified forest enhancement locations on the property. We developed a prescription and treatment units. We collected baseline vegetative data in those enhancement treatment units. We collected baseline soil samples to determine soil nutrients. And we hired a wetland specialist to evaluate the wetland sites on the property. So, sorry, I'm just gonna have a quick sip here. On our project, the aim of our monitoring and maintenance plan is really to present and describe the objectives, actions, strategies, and responsibilities to be carried out during the project's lifetime. And so once the project is complete, this document will assist land managers to act as a guide for future monitoring and maintenance requirements for the project or for their area, the land. Now, our MMP identified 6 environmental elements that required strategic assessment and management. And those were the grasslands, our forest enhancement, plantings, our wetland, our wildlife trees, and invasive species. So this here is just a cutout from like an interim report we did this fall. And it's sort of basically the framework that we're using to identify how we're managing our grasslands, for example. So grasslands is one of the bigger components in our project. And so, we thought obviously it's important to identify your objective. What are we doing there? And then we have our performance indicators. And then I just had another sort of broke it down into basically tasks, actions, and timeline sort of things. So back in 2019, we did, like I mentioned earlier, we did a grassland health assessment that provided a bunch of recommendations, and it sort of drove the next stage, which was then we wanted to get to do a soil analysis to see the nutrient content, which then drove sort of the fertilizing blend and rate of spread. This was all done in the spring of 21, and we then are reevaluating those soil characteristics again to collect that baseline information again, and then we'll be reapplying another fertilizer treatment this spring, actually. And at the end, we're going to have a review those same plots that we put in that range health assessment in 2019 and compare our sort of health scores. Another example was sort of our wildlife trees. We recognized we wanted to increase basically nesting sites, and we required essentially some additional wildlife trees to be created. So we hired Todd Manning to come out, and he was able to go and identify basically the areas where we would be good to create the new wildlife trees. And then he would develop a report with recommendations, and our timeline again would be to go back in 2-3 years to see how well these wildlife trees are responding to the treatments, and also more importantly, are they meeting our objectives? And then just have some photos of a few things that we've done. Like I said, the grasslands are probably one of our bigger components to the project. It requires a lot of heavy equipment, and we did that last spring, and we'll be doing it again this spring. So far, we've been really happy with how it's been working out. Here's some photos of just some wildlife trees that are being created. As you can see, the arborist working up here. There's a lot of different versions on how they create wildlife trees and species and ones they select. But it's a pretty unique experience to see. Here's just a few photos of sort of some of the ongoing work on the in-growth forest stands, and it's sort of we're applying a kind of a slash pile and burning with some pruning, as well as creating biodiversity piles for some small mammals. In addition, here's some photos of just some herbicide treatment on invasive plants. So just some of the key lessons learned, I thought was that, we identified pretty early on that with land managers, what practical information do they need to continue with the monitoring and maintenance plan? We developed an effectiveness monitoring plan that is sort of clear and simple. And the other thing that was important was just we maintained regular meetings with primary stakeholders and steering committee, making sure we're staying on track. Other practical things to maybe consider in order to turn your idea into a well-developed project proposal. And we've heard a lot of these talked in previous webinars, as well as today from Mike, was that, is your project achievable? Is it cost effective? Is it measurable? Are the objectives in line with the stakeholders and land managers? As well as build an effectiveness monitoring plan and include it into your budget. And then also obviously have strong support from stakeholders, letters of support, that sort of thing, and an active steering committee helps. And of course, contact contractors in advance, find out are they available, and get a quote and things like that. That'll help you develop your application with realistic timelines. And then I think Mike spoke about this a little earlier as well, but tailor your monitoring plan for the size and complexity of your project. So I believe that's all I have for you. So like I said, it was short. Thank you very much.
Thank you so much, Mark. And we will go now to some questions and answers. time, and let's see what we've got here in the Q&A box. So we'll start out with a couple of questions for you, Mike. Do you ever anticipate the planned restoration convergence zone, but also identify potential novel site convergence results?
Actually, you could answer that with a slide that I didn't show during the talk. Could I share my screen again?
Sure. Yep, you can share on top of me.
Here. Sorry. Where can I find it? Oh, here we go. Okay. Point I didn't really take time to mention is that it's advisable to have more than one reference site, if feasible, to account for the inherent variability of ecosystems and communities. The more reference sites you have, if you have a lot of reference sites, you can create kind of a frequency distribution of the indicator value that you're interested in, and that's kind of displayed here on this plot. We've got a one distribution corresponding to a semi-disturbed reference condition, and a more demanding set of conditions over here that could correspond to a pristine environment. And these vertical lines show the progress of your restoration site, the indicator value that you're monitoring over time. And if you just have one reference site, you might end up in this corner of the distribution, and your reference site might indicate to you that you've achieved your objective, whereas in fact, it's really not representative of the range of variation that you should be considering. So to answer your question, yes. It's good to consider alternative scenarios, and you can do that through looking at lots of reference sites to get an idea of what those possibilities might be. Does that answer it?
Great, thanks, Mike.
Good.
Yeah, another one for you. Do you believe there's value in measuring soil microbial communities as restoration benchmarks or indicators?
Oh, sure. It's going to be project specific though. So for a wetland pond, that might not be so relevant, but for a forest restoration or reclamation project where you're trying to restore, say, a reclaimed mine site with very infertile top layer of restoration material, you'll want that's a great indicator to indicate the site potential for that location in terms of what sort of vegetation you might expect to be supported later on. But it's going to be project specific for sure.
Great, thanks. And one more. Someone's wondering if monitoring reveals that management isn't effective, how do you decide whether more time or further intervention is needed?
That's also going to be really specific to the project. In some cases, you might know right away if the pond you've excavated to hold water isn't holding water, then within the first year or two, then that's a strong sign that maybe you could go in and dig it a little deeper or hit another water seam in the water table. For other situations such as grassland restoration project or forest restoration project, for sure things can take time to equilibrate or to settle into a pattern, a trend, and And that's why I think this idea of having intermediate targets or successional stages can really help inform that decision. If you've got an analogous disturbed site that's recovering naturally, it's really good, and your site is not at all emulating that early stage of succession, then that's a early sign of trouble. And but if it is emulating that early target, then give it time and monitor and give it time to develop. So again, specific to the project, but I think there are a range of reference conditions that you can use to help out and answer that question.
Okay, and there's related ones to what you were just answering. So I'm going to jump to them. So another one for you, Michael, that has to do with how long you recommend continuing to monitor a site after restoration. You know, what you define as long-term monitoring. Sometimes, you know, revisiting a site 3 to 5 years. You know, it has financial constraints, maybe due to grants or changing political climates. And, you know, how common is it to go out, monitor, see a site's meeting project objectives in the first few years, and then could deviate afterwards in the longer term? So if you could talk around that topic of long-term monitoring and what to look for over time.
Yeah, I think generally speaking, we don't monitor long enough. Nearly 3 to 5 years is kind of the standard that we apply for, or that funding agencies are likely to consider. But that's really minimal. That's the bare minimum, honestly. And the longer the better, especially if you're trying to come up with a time series, before or after time series, for example. Statisticians will tell you you'll need 20 years of data for a time series to show a significant effect before and after a impact. So I guess my answer is the longer the better, and 3 to 5 years might not be enough for a lot of terrestrial contexts.
Okay, thanks. One for you now, Mark. In terms of soil nutrient criterion guidelines, common for agriculture, but rare for restoration practices, what guidelines are you using to guide soil nutrient content for different ecosystems in your project?
Unmute myself here. Thanks, Marcy. Good question. Probably above my my level of understanding, to be honest with you. As a role that I play in this particular project, this is sort of the information that I would gather from some other experts, essentially. So in this case here, we used Interior Seed and Fertilizer to do the soil samples. And those soil samples are analyzed. They send them away to essentially identify sort of what's in the soils. And then I believe that information is analyzed and helps to provide the recommendations on what type of fertilizer blends and things of that nature. And this information, again, that's why I mentioned earlier in one of the slides was, you know, having a strong steering committee is important, because this is the sort of information that you would bring to them, who again is another panel of experts that would take that information and make those decisions on based on that information. I don't know if that answers your question exactly, but if you're looking for something more specific, maybe I can address that through an email.
Great, thanks, Mark. I notice it's 11 o'clock or 12 o'clock Mountain Time. And so for those of you who need to leave, I want to thank you very much for joining us. You'll receive a follow-up email with a recording, a link to a recording of the webinar. Any materials, resources that have been discussed during these webinars will include links to. There'll also be a post-webinar survey, and we'd really appreciate if you could give us feedback on that, because it helps with future webinar planning. So goodbye to those who need to leave. For those who can stay, there are a few more questions, and Mike and Mark are going to stay on with us. So I'll keep working through questions if folks want to stay on with us. So another question for you, Mike, is natural plant establishment anticipated, and how is it accommodated in monitoring design?
Oh, absolutely. I didn't touch upon that with respect to my sample example project, although it's definitely a big part of that monitoring that we're doing there. You would track natural establishment in your detailed plots, for instance, and that to me is more pertinent than the shorter term objectives of how your planted stock is doing, for example, because it's the natural succession and the natural colonization that's really going to determine whether your habitat gets to the desired state. So for sure, it's a major part of any monitoring.
Great, and here's one I'm sure a lot of people are interested in, is when you're doing grassland restoration work, how did you deal with the reed canary grass there at Burton, where you said it was covering that area, your restoration area?
Well, that's another example of an adaptive management situation for us there. The grass is as expected. It's come back strong, and it's probably the primary factor that will limit the success of that project in terms of the vegetation establishment. I don't have a good answer for how to manage reed canary grass. We'll go in there and do some cutting back, some mowing this year around the stock that we've planted, just to give them another year or two of light and water resources before they get, so they can get a little big before they get out competed. But it's a tough one, and I do not have an answer for you on how to long-term to control reed canary grass or deal with it.
No, there could be a whole webinar on that, I bet.
Yeah.
One last question here for Mark. Was fire considered instead of chemical fertilizer as a method for improving the soil health in the grassland system?
I'd have to actually speak with the steering committee about that one, because I don't believe it was on the table. My understanding, it was not on the table as far as discussion for that. I could see why people would certainly utilize that. I know that one of the issues, of course, is that we do have some invasive plant issues, and of course, some invasive plants don't respond well to fire. Obviously, fertilizing would probably help the invasives, you think, in another way, but we have an invasive management plan in place to sort of address the invasives specifically. So, yeah, long story or long answer short here is that I don't believe fire was on the table as far as a treatment.
I do have just one more point to add about the reed canary grass question. So the long-term answer is, if you can create a forest canopy, tree canopy, it will shade out the reed canary grass. The challenge is trying to achieve that sort of target in a drawdown zone where trees don't like to grow.
And the reference site that you had up there, Cartier Bay,
yeah,
did not seem to have that much. It had willows, sedges. Was there anything up there that was a potential, I don't know, in terms of your reference conditions, when you look at that community, anything there that was important to include in your restoration?
Not quite sure I get what your question is.
Oh, in terms of the reed canary grass issue. Yeah, when you look at your reference site and your reference condition, is there anything
I used a photo of a less infested shoreline from that spot, but it's prevalent there as well.
Okay.
Yeah.
Okay. Well, thanks to you both. Really great webinars and great information. Excellent presentation. So on behalf of KCP and the Trust and FWCP, I'd like to say thank you to everyone for joining us for today's webinar. Hope you enjoyed it and learned a lot. We've included a link in the chat to a post-webinar survey with just a few questions, and please take the time to complete the survey because your feedback will help us plan for future webinars. And expect a follow-up email with a link to the recording of this webinar, as well as the speaker's contact information and effectiveness monitoring related resources will be in that email. And lastly, as we conclude this winter webinar series, we'd like to thank all of you who have attended all four, and for anyone who might have missed one or would like to view them again, they'll be posted on KCP's website at kootenaiconservation.ca. So thanks again and enjoy the rest of your day.